In this tutorial, we're going to be looking at another way to solve nonlinear inequalities. In this case, so we have x cubed minus 22x is greater than 3x squared minus 24. So what we want to do is, again, solve it for 0. So we have x cubed minus 22x. If I subtract 3x squared from both sides and add 24 to both sides, I end up with this expression is greater than 0. So now what we want to do is try to figure out the zeros that would be possible for this function and figure out what those zeros are. So we can basically have any factor of 24, so plus or minus 24, plus or minus 12, plus or minus 6, plus or minus 4, plus or minus 2, plus or minus 1. And again, you can use any technique that we learned in section 4 that you see fit. There's plenty of ways to do this. I'm going to also suggest always taking a look at the graph. So as you can see here, we can take a look at what seems to match up. Well, these graphs are in a scale factor of 2 for each block. So I know that I have a 0 at -4. I know I have a 0 at +6. My only issue is I don't know what this is here, but what helps me is that I know it has to be between 0 and 2, and the only possible 0 that could be is 1. So you can see how we can kind of use those techniques to avoid guesswork for us. You certainly could have just started by looking at the graph. You didn't have to find all these factors, but it just kind of saves us some time. So the next thing we're going to want to do in this technique is look at the graph's end behavior. And we know that as it goes to negative infinity, it appears to be approaching negative infinity. And as it goes to infinity, it appears to be approaching. So in our sign chart, how that's going to affect it once we put our zeros in is we're going to have a -4, a 1, and a 6. And we know at negative infinity, it goes to negative infinity, so a negative goes there. For positive infinity, since it goes to positive infinity, a positive goes there. And since we know the zeros are going to give us sign changes, we just alternate signs in between. So we add negative to positive to negative to positive. And then since we have a greater than sign here for greater than 0, we're looking for those intervals that give us positive values, which in this case would be between -4 and 1, and also from 6 to infinity. So you can see we kind of use the trick there using end behavior as another way that helped us to avoid factoring this out. So here we have a good example that would be nice to use this end behavior technique for. Go ahead and see if you can solve this inequality.